Everybody, so like I promised yesterday, here's the first video in my new course called Aggregation, where we learn how to explode and reassemble rigid body objects dynamically. So in this first video we're going to cover the theory, so we're going to cover first just like the problems that we probably will run into, and then we're going to dive into Houdini and sort of explore how we can solve these problems. So we're going to deal with a whole bunch of interesting stuff like transformation matrices, how to blend transformation matrices together, what are primitive intrinsics, how to set up our rule systems in order to make this effect work. So a lot of interesting stuff. And you can see it's quite a long video, and this is just one video of 15 videos in total. So this will be the only video that's going to be on YouTube. If you want to watch more of the course, you can do it with the link in the description. So again, the full course is 6.5 hours, 15 videos, where we built the entire shot that you saw in the introduction. We built it entirely from scratch, and like I mentioned before, also in the trailer, like this doesn't just work on these boxes. This will work on anything. You can blow up a pig, you can blow up Taurus, whatever. So anyway, without further ado, let's dive into the actual video. I hope you enjoy, and I hope you'll learn a lot. And let me know if you have any questions. Cheers. All right, hey everybody. So first, let's do a quick sort of brief description of kind of what we want to do with this assembly setup. So I'm just going to quickly explain kind of simply how it works in a Photoshop document. And I'm also going to jump back and forth to Houdini a little bit because there's multiple setups for this online already. And actually there's this super cool blog by Nick Taylor that does something very similar, which I didn't actually see before I made my own setup. So it was kind of cool to look through his files, but he has something also you can see with assembling. So after I did my setup, I downloaded this file and I wanted to go ahead and check how he did it. And this probably also is very useful in probably 80% of the cases. I did take a slightly different approach, but that's why I thought it would be interesting maybe to sort of go over his example first. So then I can sort of explain why I'm doing it differently when I'm going to explain it in my sort of Photoshop document. And after that, of course, in Houdini itself. Right, so as you can see, he also does this assembly thing here. But there's a couple of issues. Well, it's a very clean setup, but there's a couple of issues if you're trying to get the sort of look that I'm after, where there's these pieces bouncing off each other. So they're sort of bouncing off each other, trying to find their way to the correct point, kind of. Because that's kind of the look that I was after. Because what you're going to get here is, so here's his setup. So I just downloaded his file. You can download his file on his website. So there's, I'll put this link in the description, but you can download the zip file here. He's sharing that, so that's pretty cool. Anyway, so here's his file. So I just put my boxes in, and you can see it also just assembles together. So it's pretty cool. A couple of things that you might notice. Right, so they do penetrate quite a lot. And that's, I mean, a little bit like they're gonna penetrate a little bit also in my setup. Like you cannot get around that. I mean, eventually they do need to sort of move into position and you cannot get it perfectly. So, well, I guess maybe you could if you do some very advanced math, but you're gonna fake it a little bit. But for me, this was a little bit too much, if I'm honest, for my setup. And this will probably be fine if you have like a like if you have a character falling apart or something and it's like reassembling, it's like tiny pieces of rock or something, and then this would probably be completely fine. Another issue that I had here was if I enable a collision object. So they're gonna sort of be pulled through the collision object, and like I have my ground thing, right, with all of the collision things, and you could also even put stuff in between with me and then they would just move around it. So this was another issue that doesn't work in this use case, but this is a very simple, like it's a very clean setup. Like it just uses one wrangle. Mine has a little bit more checks. So, but I did want to show that this is probably, if you're just gonna do a like self-assembling character or something like that, and you don't really have to deal with stuff moving through other colliding objects, you just want something very clean to self-assemble, that this is probably a good solution. However, let's now just jump into Photoshop, and then I'm gonna explain what this is doing and what I'm sort of doing differently and what we need to build inside of Houdini in order to do our self-assembly setup. So we have this thing here. Let me just quickly say, let's put all of these in a folder in case we need to go back to our sort of original thing. All right, so let's shuffle these up a little bit. Let's put it to auto select, and let's just pull them off. Let's put them to random positions. Right, so let's say we have a partially sampled thing. Right, let's just put that one here. And let's maybe say, all right, this one as well, and this one, and let's also do this one. Right, so we have all of these pieces, right? And we want to start having them pulled to their original location. So this one needs to go over there, and like this one needs to go over there. So they all know their sort of original positions, right? So what we're gonna do is we're gonna create forces. Let me just make a sort of layer that I can draw on. Right, so we're gonna make these forces. Let me do it with a red arrow. And so like this one's gonna get a force over there. This one's gonna get a force over there. So it's gonna have this force working on the thing. And what's different in, for example, Nick Taylor's thing is he's not using forces. What he's doing is he is taking the rest position. So let's say we have this thing, and this is going to be its rest position. So this is his goal position. And what he's doing, and also what I'm doing, by the way, for part of my setup, is I'm blending the position and the orientation. So let's say also maybe this one is oriented differently. So blending the position orientation from this position to this position. So it's going to orient back to where it was, like boop, and then it's in position again. So he's doing that over a certain time. So each get like a random value, and then it's gonna like say, okay, over the next 2 seconds or like 50 frames or whatever, you're gonna go from here to here, like you're gonna match your orientation. So it's not forces, it's literally blending position orientations. All right, but what we get for a problem then is, let's draw a collision object. So let's do let's make another color. Boop. Right, so let's say we have a collision object here. And we're gonna blend the position from this one within like 2 seconds from here to there, right? Right, so it's gonna go like beep, 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 and it's gonna be here. And it's gonna be like, okay, I have to be here within the next second, else I don't adhere to the code that's being given to me, because I need to be there. Like, it's an absolute rule. Like, I cannot get around this rule for me to be there within the next second. Right, so what it's gonna do, it's gonna try. Okay, now we need to really pass through it. So there's no sort of check going or like extra forces working its way around it. So that's kind of what's doing here. Like I can quickly go in here. I gonna get into this stuff he's doing here, but he's essentially grabbing the transformation matrix and the position, and he's sort of interpolating between the position and the rest. Don't worry if you don't get what's happening there, but we'll get into that. So anyway, but there's no like actual there's no other check to happen, right? So what is the different approach that we're gonna take in my sort of setup? And again, my setup is not necessarily better. It's just a different setup for the look that I was trying to get after, of them sort of bouncing around, because I wanted them to be able to do this. Like, for example, I wanted them to just draw a line again. For example, I want this one to be like boop, boop, boop. Right, I'm searching. Boop, 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 boop. And I finally find it. So it's kind of like gonna bounce around, and finally it's gonna move into position. That's kind of the look that I wanted to go after. It's a little bit more chaotic, but I like that sort of look. But if you're fine with them just going like that, and even maybe with like some divergence. Like you can still add some noise. Like in this thing, I could still add like a pop force, for example, and it would still work. So I mean, you can still add these forces. So that's not different, but it's just a different approach. Anyway, so what is my my approach to this? Well, what we're going to be doing. Let me make this more red because I'm annoyed by it not being all red. Right, so we're just going to introduce forces on these things. So first we're going to sort of have a base force. So this thing knows that it needs to go over there. So that's its goal position, sort of. Right, so there's a force drawing that way, right? So it's first going to just be pulled over there. But there's also other forces. Like I might have a noise force. It's going to... Oh. No, I don't want to do text. So there's like other forces that are going to go around. So there's other forces, like we have a noise force. So it might be like noise that's like borrowing all kinds of directions. But it's not blending the position. It's just literally a force. So if it encounters this object, maybe it's going to be picked up by like this other thing. And there's still this force working on it. So it's going to work its way like around the object. Then it's going to be here. And eventually it's going to... let me just grab that. So eventually it's going to make its way sort of to around the position. But of course it's not going to snap into position because it's never going to, just having this force here is never going to put it completely in position. So what are we going to do? Like let's say there's this sort of magical barrier around our object. So let's do this and let's make a... No, I'm really messing up with this Photoshop thing. All right. And I want it to be red and I want this to be red. All right, let's make it a little bit thicker, like 5. All right, so there's this magical barrier that's going to be sort of around this object. It's going to, in each of these sort of goal objects are going to have like their own magical barrier. All right, so let's say that, let's put a center in here, maybe not, just right. So there's going to be this magical barrier. So there's this, he has this goal position here. And all right, so he's just going to be pulled here. And he's going to be like, burp, 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 burp. All right, so what happens when he gets inside his magical barrier? Right. So once he gets inside, we're gonna start blending these positions, and we're gonna do that very slowly. So we're gonna add like a little value from it to blend its position. So let's say 0.05 or something. So it's gonna blend between its original position and its goal position by a little bit. But there's still these forces working on it, so it's still not completely doing the blending. It's still like there's still these noise forces like going all around the place. Burp, 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 burp. Right. So it's gonna do it a little bit. Right. So it's gonna be pulled there, but it's gonna bounce around like right. So eventually, if it's trying for too long, because we're also gonna maybe like run a timer. So how long have you been trying to get to your position within this area? So maybe every second, every frame we add like a little bit to a timer. So so like an age, like we start aging it once it gets like a bit in here. And then let's say, okay, after you reach a certain age, so let's say you've been trying for like 1 second or 2 seconds. After you've done that, stop trying to do the collision stuff and completely move to your position. So then it's going to ignore the position, and then it is going to sort of move through the other stuff like we saw over here. So where they're sort of moving through each other. But it's not going to do it initially. It's really going to sort of first try to get to its position by itself. And then eventually it's going to be it's gonna stop. It's gonna ignore all these collisions here. It's gonna be inactive, and then it's gonna be pulled towards its original position. So to sort of round up what we're doing here is first we're grabbing our just do it like that, right? So we start adding forces to our boxes. It's gonna try to find its way. When it's gonna get into this circle, this cylinder thing, then it's gonna slowly blend in the position. And then when it's been trying for like way too long, then we're gonna deactivate it, and then it's allowed to move through other objects. Right, so that's kind of the setup that we're gonna need to build inside of Houdini. So if this sounds complicated, it's not too bad. It's just some if and else like statements. So with that out of the way, hopefully that was somewhat clear. And now let's dive into how we can actually build this inside of Houdini. All right, so we're inside of Houdini. So let's first just start explaining sort of how this thing works of like blending positions. We're going to be using this mostly in Vex. I know some of you prefer VOPs, but the stuff that we're going to be doing is just easier in Vex. And in this case, because it's a slightly more advanced tutorial, I'm not going to do the thing both in VOPs and in Vex. I'm just going to be doing this in Vex because truth be told, like some stuff just with more complicated things that you're doing, it's just personally I just find to do easier in Vex. So just to get it out of the way, we're going to mostly be using Vex. But I am going to clearly explain what everything is doing, so hopefully it'll still make sense even if you're not like a Vex wizard. I'm not a Vex wizard myself either. I just know enough to make certain stuff work. Right, so let's just make a box. Let's do points from volume. Let's just make it like this, and let's do a Voronoi fracture. Let's just first fracture this. Right, let's assemble it. And let's do for now do a attribute VOP. Let's add some noise to these positions. Because what I want to just first do is just do this in SOPs to sort of go over kind of the stuff that we're going to be doing. Because it's just easier to do stuff in SOPs before you start diving into dynamics. All right, let's add those positions. Oh, we need to pack this. Let's promote all of this stuff. Do Berlin, I always mix these up. Right. So now they're sort of like, well, pulled to a different position. Right, so we have the original position here. Let's maybe make a null to sort of make it a little bit more clear what we're doing. In position, all right. All right, then they're deformed here, and then we have this other thing. All right, so let's do a wrangle, dispute wrangle. We're gonna do it on positions. All right, so let's just first try this with just a regular position interpolation. So just that's simple because it's going to be just a simple vector. Later we're going to be using matrices, which are a little bit more confusing also to me, but like as long as you know how to sort of use them, then it's pretty okay. All right, so let's do let's import the position of the second input. So let's call a vector. Let's call it pulse. So for position, you could call this anything. Like I mentioned before in my other tutorials, you could also call it cheese, but pulse just makes sense because it's going to be position. All right, so it's going to be point, and we're going to do it from the first input because that's that input, right? All right, what do we want to call? We want to call the position, so as a string. You can hover over this to sort of, is it actually going to do that? Okay, normally it also gives sort of an explanation of what it's going to do, but we're going to just press F1. You can see string, the attribute name is a string, and then the index, so that would be the Right, it's the point number. So it's going to match it by the point number. Since the point numbers are the same, this will work fine. Right. Right. So if we want to sort of interpolate between these, what we can do is we can say that we want the position, so v at p equals. Then we want to say lerp, which means linear interpolate. So makes sense, right? Between the current position, the position, and a mix value. So let's say make a slider, channel float, mix. Oh. Right. So let's make slider. If we now drag the slider, you can see we're sort of mixing these positions together. So this is kind of like what a blend shape would do, right? So if we do blend shape, I mean, essentially that's sort of the same as we're doing here. Like it's probably completely the same if we link up these values. You can see it's actually that's what the blend shape here is doing. So yeah, there's that, but we cannot just do that because in our in DOPs, right, they're also gonna have like orientations. So because we're gonna be rotate a little bit, so there's gonna be all kinds of stuff like that. So we also need to account for the orientation. So how are we gonna do that? Right, so I recorded this earlier and then I ran into a little bug, which apparently there is in Houdini 18.5. So let me just discuss the bug and how I ran into it. And how now that I figured out what the bug was, we can continue because this is something that you would work in earlier versions of Houdini. Anyway, let's put down transform pieces. Transform pieces, and transform pieces will allow you to transform pieces. So what it does is it takes input geometry, rest geometry, and template points. So if I were to, for example, put down a transform in between here, right, then it would transform these pieces based on whatever is in here. However, what I want to do is want to put an attribute randomize. I want to do it based on an attribute. So if I put an attribute in here, and then put in orient, and then put it into orient is a quaternion. If you don't understand what the quaternion is, neither do I. Well, I sort of understand a little bit. Well, I know how to use it, and that's enough. It's a mathematical way to sort of to set orientations in 3D space without running into gimbal lock. So gimbal lock is where sort of two axes of a transformation are sort of on the same row. Let me just see if I can find a video for that. So here's kind of explained. So like in a regular transformation, you can see some can be on the same axis, and that can sort of give some issues. There's probably more videos here. Anyway, that's gimbal lock. You might have probably already run into that a couple of times. But anyway, quaternions don't have that issue. But so if let's put this inside sphere. But if you can see here, well, this should rotate them, but it's not, and there's a bug because apparently now in the new Houdini versions, this doesn't want to take geometry in the input, only points. So if I, for example, make a add here, put it in there, delete geometry, keep points. If I do another transform pieces, put the geometry in here, put the rest points in there, and do it in there. You can see now they are certainly oriented correctly. So I'm not sure why they haven't done that in the node itself, because what you could do is just go in here and they could just do it like that themselves. And you can see that would also work. So I don't know why they haven't fixed that yet, but maybe they will. Maybe by the time that you're watching this, this is already addressed. Anyway, now they have random orientations, but if we do this, you can see it's not really working. Let's, by the way, move this around a little bit and let's do it like this. Let's go from this to this thing. All right. And oh yeah, let's go from this to that one. Right. So you can see if we do this, well, the positions are still blending, but their rotations are not blending. And if we go to our points here, you can, well, we don't really have a rotation attribute, right? So how are we gonna do that? Well, actually, you do sort of have a rotation attribute, and it's a transform intrinsic. So let's talk a little bit about that. So essentially, a intrinsic is something that's computed on the fly by Houdini in some primitives here, and you can see there's a whole bunch of intrinsics. You don't really, well, you don't look at these by default. There's so many of them, but for example, what there's a packed full transform, and this essentially has the full transform of our thing here. So you can see if I go on here on our thing, you see they're all at 0 because they are not rotated. And if I go here, you can see they're all rotated. If I were to disable this, well, they still have their transformed position here, right? So this is still the position information, but you can see the other things are 0 because they don't really have any rotation on them. So we can use that. So if essentially this thing is a matrix, and I sort of, the matrices are a little bit complex, but I sort of understand them, and I'm not a complete master of them. But let me just quickly explain kind of what they do. So if we have a look at this matrix here, and let's count these rows. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16, that's 4 by 4. And 4 by 4 matrix is a transformation matrix. So if I go to transform, if we have a transform here, it's actually also a transformation matrix. So let's assign this to, let's put it in here. So actually there's a extra column over here that you don't see, which is just hidden because you don't really look at it. But essentially transformation like this is a 4 by 4 matrix. And if I am going to manipulate this stuff, you can see my intrinsics here are changing. So that's a 4 by 4 transformation matrix. All right, so what we can do is we can load those in and then apply them. So instead of just doing our position like this, let's do it with a matrix instead. So let's do it like that. So if you want to know more about matrix stuff, just check out this guy's channel, Junichiro Horikawa. His channel is absolutely amazing, by the way. He has so many cool Houdini stuff. It's very technical. Absolutely amazing channel. So shout out to you. You make amazing stuff. Anyway, he has a whole thing here explaining matrices. So if you want to know more about matrices, probably check this out. So he goes a lot more into, like, he goes really into depth on what they are. So that's super cool. With that out of the way, let's just start using the matrix. Let's enter the matrix. Yeah, so let's load in our matrix. So let's load in both of our matrices. So let's type matrix. And if you type matrix, just regular matrix is a 4 by 4 matrix. That's just the default matrix. You can also make a matrix 2, matrix 3, but default is 4 by 4. This is the standard, the thing that you use most of the time, because that's a regular transformation matrix. So let's call it M1, and let's load our packed transform. So that's the essentially the transformation that we have here, packed full transform. So essentially that's the full transformation matrix that our packed geometry has. So we can load that in. So get packed transform from first input from the current primnum. All right. Now let's copy that. And let's also do it from our second input. So let's create a second matrix from our other input. So that's going to be this one. So we have, first one is this, the other one is that one. All right, and by the way, let's just create a float here for mixing. So float mix equals general float mix. And I'll just grab this thing. It's just easy, gonna be easy to use. Right, so now we wanna create another matrix. So that's our mixed matrix. So what we're gonna do is we wanna mix between those, and we cannot use lerp because that's that's for vectors. We only use slurp, spherical linear interpolate. So yeah, this is used for quaternions or matrices. You can see stuff in here. So yeah, we're going to interpolate, pretty basic. M1, M2 with mix. Right, so we can mix these. Well, you don't really see anything happening, but I can assure you it is actually happening. If you don't believe me and you want to see that I'm not lying, I understand that because of course I'm such a liar. So we can type 4, which means a matrix 4, my matrix equals M3. All right, so we can see, oh, we have a whole matrix here. It's so much data. And if we do this thing, you can see it goes from whatever it is here to 0. Perfect. Right, so we don't need to write it out because it's so much information. I mean, we only need to use it in here, right? So what we need to do is we need to just set it. So set packed transform. So we open up the help file. So very simple. And this combines essentially just setting both the orientation and the position. So super useful. So we want to do it on the first input. We want to do it on the current prim number. And we want to do it on the M3 matrix. All right. So if we now do this, you can see, hooray, we're sort of mixing between our original position and orientation. All in one function, so that's super useful. So in this version, which again isn't mine, he does it separately, so separate for the position and for with a set prim intrinsic. So you can also set intrinsics. So this is just one function, which is super useful. You can also set these intrinsics yourself. Which if you haven't checked out my regrowth series, you can also do that, for example, to override, for example, the time on alembics to do cool stuff. So if you haven't checked out my regrowth series, that's also on the channel, because we also use that over there. Anyway, so this is essentially what we're going to be doing. So we're going to load the matrix, and then we're going to blend from the original matrix to the other matrix. All right, so now let's do this thing what I mentioned in my ugly sort of Photoshop thing that I had here, of that. Let's say if I have this box here, let me do auto select. Right, so if I have this box here and this box needs to go there, that it's gonna sort of it's gonna like move through it, but it's only gonna do it like if it's a certain distance. So it's gonna be pulled through it with like a force, and it's only gonna move into position. So that's the moving into position stuff. It's the thing that we just did here, right? It's only gonna do that if it's like close enough. Before that, it's just gonna be a force. All right. So let's think about how we can do these things. So I guess let's just name all the stuff that we've been doing. So I guess set position. And again, all this stuff that we're doing here, we're going to do this inside of DOPS later. So we're going to make this dynamic, but it's just easier to sort of explore what we're doing in SOPs first before we start complicating it, doing it in DOPS, because DOPS just makes it more complicated because we're going to do this every frame. So yeah, let's do this sort of measuring thing that we did before. So let's draw an actual line from the position to the goal position and then measure its distance. Right, so let's go over there. So what we can do is do another angle. So let's plug it in there and let's put the original position. So that's the original position here into there, right? So let's first draw a little line. to sort of visualize what we're doing here. All right, so what we need to do is import the position. We just maybe make this a little bit bigger like this. All right, so let's maybe import the position from this input. So how can we do that? Well, we can just type vector. Let's call it, I guess, let's just say P2 in this case, second position equals point, first input, position, and we're gonna match it by the point number. All right, so what I can do now is I can say, for example, is let's draw a vector from current position to its original position. So let's, I guess, template the original positions here. All right, so what we need to do is we need to say v at tier equals current position minus the other position. You can see now we get sort of a vector. Let's press in the viewport, make a visualizer thing. So if you press D in the viewport on the keyboard and then go to visualize, right, can this thing, let's go to marker and let's make it vector trail and type dir. And then probably we need to move this before it will start cooking. All right, there we go. You see now we get these lines, right? That I was also drawing inside of Photoshop before. So we get these lines and you can see if I, so they start at the original position. I guess I could maybe make it a regular vector. No, just make it a, no, just make, let's keep it at vector trail. Kind of wanted to not have sort of an arrow. Anyway, it doesn't really matter. So what is happening here is it's drawing a line, like you can see, from the original position here, center of the original position, to wherever it is after that. And now I accidentally did some stuff there. All right, so that's step one. All right, so another step. And maybe if we want to make this a little bit more clear, we're doing a position that maybe could also, because I know I need to do this in the, when we're doing this inside of DOPS. Let's just also just regularly load in our position here, just to make it a little bit more clear what we're doing. Again, so this also works, but now we could just say P1 minus P2. You can see it does the same, just looks a little bit nicer maybe in this case. All right, so another thing we want to do is we want to calculate this distance. So that's very simple actually. Let's say f at dist. So for distance, I over just type distance like this, it's also fine, equals distance. All right, easy. So the distance from P1 to P2, all right. And why is it not, oh yeah, there we go. Distance, you can see now we get a distance value, and maybe let me split this open again. Right, so let's link this to first thing, then we can control it over here. Right, so if I now animate this, you can see it goes from 0 to whoop. Right, so now that we have this thing, we can use some fancy, just some simple wrangle or just some simple code to start doing some interesting stuff with this. So for example, we could assign them a certain color once they get close enough. So you could say, like, if the distance is like super close, let's give them another color. So before we do this, I want to point something out that I'm not sure what's up with this in Houdini 18.5. But if I do, if you attribute randomize and you make random color, it doesn't show the random color. It does it on, shows it on primitives. It does show it if I were to unpack this and transfer it to points, but for some reason it's not showing the colors properly on the pack.geo. So if someone knows what's up with this, let me know. So I'm going to use primitive colors in my wrangle because we're going to assign these colors, but just pointing out that that's why I'm going to assign primitive colors. So let's do a little if statement. So let's say that if the distance is below, let's say 1, then we're going to do something. Let's open and close these things. And then let's set primitive attribute. So then again, normally you would just set this as color, but I'm going to set it as a primitive. So what do we want? Is want so what do we want to set? We want to set color, primnum, the value we want it to be red. So let's do something like this, and want to set it right. And we want to use, yeah, let's type over here before we write it out, just type float distance, and then maybe f at distance equals distance. All right. Just doing this so we also have it just as a thing here, so we don't necessarily need to write it out. Let's just do the writing out thing over here. All right, so now if I move them closer, you can see them slowly moving in and turning red. And what we're doing here is just setting color, right? We could do other stuff. We could also say that remove point like we could remove them. You could do anything. In this case, what we're gonna do once we start taking this into DOPS is before all the stuff, we're just applying the forces, right? The little vector thing that we have here. If it's doesn't want to show, yeah. So we're first going to apply just the force, and then once it gets close enough, then we start doing this back to transform thing. Yeah. So essentially, that's the sort of basic thing, the basic stuff that we need to know in order to be able to do this inside of DOPS. So now that we got the basics out of the way, I guess we can take this into DOPS and make the actual sort of setup. Of course, that's going to be a little bit more involved, but the basic math is essentially just the same. I guess we would say here is create vectors. Like the basic math is the same as what we were doing before. So yeah, I guess let's take this into DOPS and let's apply it on an actual dynamic simulation.